So my screen is visible. To find N Point DFT using equation and verify it using built-in command in Scilab. So this is the comment I have written there. Yes. Clear. What this clear does, this will clear the previously stored values in the variable. Close. If at all any figure window is open, it will close. And one more is CLC, right? So CLC. What is the CLC does? It will clear the console window. So these three lines of code is mandatory in whatever the code you are going to write. Okay. Yes, it is x of k. Left hand side is x of k. Summation n varying from 0 to n minus 1 x of n e power minus j 2 pi by n into k. Right. Now what is k? K will address the sample, right? K will address what domain sample? Time domain sample or frequency domain sample? Bin number, fine. It's not. Yeah, it is addressing the samples in frequency domain, no? And what about n? It is addressing the samples in time domain. And both are a single number or it takes some bunch of values, k and n. Is it just one constant or does it take values? Okay, both n and k are varying from 0 to n minus 1, right? And x of n is the input signal which is in time domain, and x of k is the output signal which is in frequency domain. And we have some trivial factor here, but that we will see later. Fine. So we shall try to implement this equation to find DFT of a given sequence. Okay. Now, so we need to read x of n, the signal in time domain, and we need to read number of points. For a given x of n, I want to find whether 4-point DFT or 8-point DFT or anything. So generally it is capital N. Take it as small letter x, saying that it is in time domain, is equal to, so input is a command which will read the values which we give in the console window. So in a single code, I have to write the message, enter number of points, right? I'm sorry, this is input, no? Enter input signal x of n. What else I need to read? I need to read number of points, capital N is equal to input in a single code, write the message, enter number of points, capital N. Input. Okay. What do we do next? I have read the signal x of n. I read this signal x of n, right? And I have read how many points DFT I need to find, the value of capital N. What else we shall do? I have both x of n, I have capital N. What do we do next? Statement here. So small letter n is varying from 0 colon capital N minus 1. So this is saying that you start from 0 and end at capital N minus 1. Okay, colon says that up to where? 0 to n minus 1. This is how we write. Okay, so by default the step size is 1. If you want step size as 0.1, you have to give in between one more argument 0.1. But I don't want the step size to be 0.1. I want step size to be just 1. Okay, so this step size we have used in the previous experiment to plot sine wave, right? So by default it takes an integer, one single step size. Fine. So n is varying from 0 to n minus 1. What about k? K is also varying from 0 to n minus 1, right? So what I'll do is I'll write it as k is equal to n. Is this fine? Okay, fine. So we'll run it. Let me save. DFT demo session. We have to put it in a square bracket, in between square bracket, separated by comma, 1 comma, 2 comma, 3 comma, 4. This is my input sequence. X of n is equal to 1, 2, 3, 4. Hit enter. It is asking enter the number of points, capital N. I'll write. So minimum number of points I can take is 4. Okay, so I'll give 4 here. So I will hit enter. So no error, no issues, but I need to check k, what is there in k. I'll just type k and I'll hit enter. So k is varying from 0 to n minus 1. Capital N is 4, so n minus 1 is 3. So k is varying from 0 to n minus 1. Similarly, I want to check what is there in n. So n is also varying from 0 to 3. So fine, no issues, right? So we'll go back to the code. Now first I will define kn. I'll say what is kn. Okay, so you need to take care of this kn here. I'll tell you what's happening. So first I will define k times n. Okay, kn is equal to, when you multiply these two, there are two possibilities. One is it will happen cross product, otherwise it will happen dot product. How is it? If I just multiply k with n, what do I get? What are we expecting? So mind you, k is not a single number, n is not also a single number. K is varying from 0 to 3 and n is also varying from 0 to 3. Okay, as per the equation, as per the DFT formula, what I need is kn. Again I repeat, k is not a single number, it is varying from 0 to n minus 1, n is also varying from 0 to n minus 1. What I need is kn, so that I can implement this equation. Okay, I want to define kn. So is this valid what I did? Do we get, I mean, what are we expecting in this nk line? No, the thing is, let me just try to convince you with the console window. Okay, what do I have in k? K is varying from 0, 1, 2, 3 and n is also varying from 0, 1, 2, 3. The thing is, when you are taking kn, you just take care that you get a matrix, not a constant. There are two possibilities. So what do we get if I multiply a column vector with a row vector? Do I get matrix or vector? Okay, so the thing is, no, if I multiply k with n, I get error. Okay, so I cannot multiply a column, a row with a row. Okay, this is doing usual matrix multiplication. I cannot multiply a row with a row. Okay, so dimension error we get. Either I have to multiply a column with a row, or I have to multiply a row with a column. Okay, two cases are there. What I need is, when I multiply k and n, I need to get a matrix of size 4 cross 4 in this example, because x of n is 1, 2, 3, 4. This length is 4, no? Whenever I multiply k with n, I should get a matrix of 4 cross 4. So what should I do? Is it a row versus column? I mean, row multiplied by column or column multiplied by row? Column multiplied with row. Okay, and this is in what? Row or column? Both k and n are in terms of row or column? Okay, both are in row wise. So okay, I have to convert it to column. I have to transpose that vector. So in Scilab, transposing is nothing but you just have to put this single quote. Can you see this single quote symbol? So you have to put this single quote symbol. So k is a row. Now if I put k transpose, it will convert it to column. Okay, this is how we transpose a vector or matrix in Scilab. Okay, now so if I do k transpose multiplied with, so this is column, right? K transpose is a column. K transpose multiplied with n, where n is a row. So what am I expecting? I am expecting a matrix of size 4 cross 4. This is what I need. Okay. But if you do the other way around, if you do k multiplied with n transpose, you will get a constant 14. So this is called as dot product and this is called as cross product. I hope you know that. So just make sure that when you multiply this kn, as per the equation, when you multiply this kn, so it should give you a matrix. If you are finding 4-point DFT, it should give you 4 cross 4 matrix. If you are finding 8-point DFT, it should give you 8 cross 8 matrix and so on. Okay, for that, make sure that first is column and second one is row. Okay, column times row will give you the matrix. Now, so what is that I need to change here? So I am defining kn here. Let me convert it to kn is equal to, now kn is a variable. So k transpose multiplied with n. So now I have matrix in kn. Fine. So now what else we shall do? So we shall going to implement that twiddle factor. So I am done with this kn. I'll try to implement this twiddle factor e power minus j 2 pi by n. This is nothing but twiddle factor, no? So w n. So twiddle factor is equal to e power is ext, okay, e power minus I, you have to put with a percentage symbol, e power minus I into 2 into pi, again you have to put it in a with percentage symbol, percentage pi, 2 pi by capital N. Mistake, yeah, one thing is minus I multiplied with e power minus I into 2 pi by N. Fine. So this is our Twiddle factor, and this has to be multiplied. So this Twiddle factor has to be taken in power of x of n, right? So it is Wn power Kn. So this Kn has to go above this Wn, right? So what I'll do is, so ultimately I get a matrix W is equal to Wn dot power Kn. I'll tell you what is this dot power, but for just time being, so W is equal to, W is now a matrix. So do you remember DFT as linear transformation? We had a matrix and we had a vector, and we used to multiply matrix with a vector so that we get DFT sequence, right? So that's what happening here. Now W is a DFT matrix. If I'm trying to find 4-point DFT, this matrix will be 4-point DFT matrix. If I'm trying to find 8-point DFT, this will be 8-point DFT matrix, and so on. Fine. Now the question is, what is this dot power? Why did not I put just power? Why did I put dot power? So let me convince you with the console window. Okay, let me just clear it. CLC. Say I have x is equal to 4 numbers. I will randomly put the numbers 1, 2, 1, 3, 5, 4. Okay, so I have one more variable y, and this is equal to say minus 1, comma 1, comma 1, comma 1. Fine. Now whether x into y is possible in this case. If I try to multiply x with y, what am I expecting? It's not possible, no? I get error. Yeah, the dimension will mismatch. Correct, no? But I can do element by element multiplication. What I want is, I want this 1 is multiplied with minus 1, 3 multiplied with 1, 5 multiplied with 1, and 4 multiplied with 1. Okay, whenever you want this element wise multiplication, I have to put dot x dot star y. So whenever I put dot followed by any mathematical operator, so what I am doing here is I am doing element by element. Okay, so 1 is multiplied by minus 1, 3 is multiplied with 1, and so on. Enter, so I should get the element wise multiplied result. So 1 is multiplied with minus 1, I get minus 1, and 3 times 1, 5 times 1, and 4 times 1, I get 3, 5, 4. In this, yeah, in this case also, in our case also, since we are defining a DFT a matrix here, so the power what we are taking, no, it has to be element wise power I need to take. Matrix wise, that Kn is a matrix, and this Kn first row first element has to be multiplied with Wn. Okay, first row second element has to be multiplied with this Wn, and so on. Every element in the matrix has to be multiplied with this Wn. Okay, so that's the reason. This is what I wanted. So that's why I have taken dot power. Okay, if you take power, I think you get error, or you may get some other matrix, but I don't want that matrix. What I want is dot power. Fine. Just we'll try to run it and we'll see. I'll stick on to that sequence 1, 2, 3, 4. Is asking enter. Okay, fine. No errors. Let me check what is there in Kn. Kn should have that matrix. We have that matrix. Let me check what is there in W. W should be a 4-point DFT matrix now. Okay. So if you check, so this is 1 plus 0i. Just ignore this 0 i's. This is 1, 1, 1, 1, and this is also 1. This is also 1, and this is also 1. Fine. And this is basically 0. So don't get confused with this. What do you mean by this? So I have 6.123. So this is 6.123 D minus 17. So don't get confused. How do we read this? This is nothing but 0.0000 up to 17 times 0. Okay. So I repeat again, 0.00000 up to 17 times 0. After 17 times 0, it is 6123. This is how we read it. This is basically 0 only. Okay. So 0.0000 up to 17 times 0, 6123. So this is nothing but 0. Fine. So this is minus I. So if you remember that, if you remember that DFT matrix, 4-point DFT matrix, first row everywhere 1, first column everywhere 1. So this was minus j, this was minus j, this was plus j, this was plus j, and minus 1, minus 1, minus 1, minus 1, and in the middle it was 1. Okay. If you look at this matrix, you get the same kind. So this is nothing but 4-point DFT matrix. Okay. So once I get 4-point DFT matrix, how do I find the DFT? I just have to multiply that 4-point DFT matrix with the input sequence x of n. Okay. So that I get my DFT. So that's what I'm trying to do now. So capital X, okay, capital X, saying that it is x of k. Okay. Capital X is equal to, so W times a matrix times vector, which is x. Okay. If I run this, I get error, and you have to tell me why is that error. Let me run it. Okay, it is asking me enter the sequence 1, 2, 3, 4. So it is 4th one. I'll get 4. So I have an error in line number 25. I have error at line number 25, and it is saying that inconsistent row column dimension. Okay. So what is that line number 25? I have this. Okay, this line. I have an error, and it is saying that inconsistent row and column. So can anybody tell me what is this error? Okay, let me give you a clue. So let me display what is there in W and what is there in X, so that you get some clue what's happening. So capital W is equal to, it's a 4-point DFT matrix, and small letter x is equal to the sequence 1, 2, 3, 4. You might have got an idea why it is an error. Yes. So while solving the problems, it was like a matrix with not row, with a matrix with a column, right? X of n we used to put it in a column. So this has to be converted into column. This x has to be converted into column. How do we convert it to column? You just have to give a single quote symbol here. Fine. Now we shall run it. We give the sequence 1, 2, 3, 4. So hit enter. Enter the number of 1, 4. Okay. So what is there on which variable I have? Okay. Capital X has the answer. If I just type capital X and if I hit enter, so I get. So we got 10 minus 2 plus 2j. This is basically 0. Okay. Yeah. This is basically 0. So don't get confused. Fine. So this is nothing but minus 0.00000 up to 16 times 0, 999797. This is basically 0. So what we get is 10 minus 2 plus 2j minus 2 and minus 2 minus 2. Yeah. So we are done now. So let me display the result. So command is DISP of, in a single quote, write the message 4. DFT of the given time domain sequence is with a comma, close the quote, put a comma, and the variable where my result is there, which is capital X. I just give capital X. Try to run it. So go back to console window. I give 1, 2, 3, 4. Number of point is 4. Okay, so this is what I am getting. DFT of the given time domain sequence is 10 minus 2 plus 2j minus 2 minus 2 minus 2. Yeah, we have to find magnitude and phase angle of this x of k, right? So we'll do that. It's not that complicated. We have inbuilt function to do that. We'll do that. So let me call it as capital X underscore MAG to get the magnitude response of x of k. Okay, is equal to, command is ABS of, so x of k, and where is x of k? X of k is in capital X, so I'll put it as capital X. Fine. Now I'll display it to this, and I'll have a message saying that magnitude response of the, it's better I just put as magnitude response, and comma, and where is it? It is in capital X underscore mag. Okay, so similarly, okay, before that let me just run it and I'll show you also. Let's save and execute. So 4. Okay, so DFT is 10 minus 2 plus 2j. So this is fine. Okay, fine. So we'll try to find the phase angle. Again, phase angle, not a big deal. We have inbuilt command in the Scilab. So I'll take it as x underscore VTU phase angle is equal to A tan. A tan stands for tan inverse of. Okay, A tan of imaginary IMAG, imaginary part of x of k, which is x in our case. X of k is x in our case. Okay, imaginary part of x of k, comma, real part of x of k, but in our case it is x. Fine. So we shall have a display saying that phase response, comma, and that value capital underscore phase. So try to run it. So this is 0 because 10 is a real number, I get 0. This is 3.356 and minus 2.326. This supposed to be 0, but I'll check and I'll let you know later. Okay. For time being, you keep it as it is. This supposed to be 0, right? Yeah, this supposed to be 0, but what we are getting it as minus pi, because 3.142 is pi, right? In terms of radians, if I write in terms of pi, this is nothing but pi. So this is minus pi. So it's supposed to be 0, but I'm getting minus pi. I don't know. I just need to check what's happening here. For time being, we shall stick on to this. This is supposed to be 0. Okay. So we are done with one part of our experiment. Okay, which was finding DFT using equation. Now we have to verify this result using inbuilt command in Scilab. That is again not a big deal. The command is FFT. Okay, so there is an inbuilt command in Scilab to find DFT, which is FFT. Basically, if I have a sequence X which is 1, 2, 3, 4, and if I want to find its 4-point DFT, it is just capital X is equal to FFT of small letter n. So time domain sequence X of n has to be passed inside the FFT algorithm so that I get frequency domain signal X of k. So if I hit enter, I should get 10 minus 2 plus 2j minus 2 and minus 2 minus 2j. I need to find even its magnitude and phase angle, and I already told you. So how do I find magnitude? X mag is equal to ABS of X of k, but X of k is in capital X. So it is 10, 2.828, 2 and 2.828, and phase angle is XPHAC is equal to what was the we had? Okay, A tan inverse of first parameter is imaginary IMAG of X of k, which is X here, and REAL, real of X of k, which is X in our case. If I hit enter, I should get 0, 2.3. Again, there is an ambiguity here. We had, where is it? So I got minus pi here. So using inbuilt function, I'm getting plus pi. So let it be like this. I'm trying to see what is the mistake here. But everything is correct. No, only 0 I'm getting like this, but these three are matching. Okay, say I want to plot this phase, I want to plot this magnitude, and I want to plot this X of n. So how do we do that? So totally we have 3 figures, so I should have subplot of 3, 1, 1. So figure, subplot, 3 rows, 1 column. In that first figure, I want to plot X of n. Okay, and where is my X of n? X of n in small letter x variable, right? And what is its x-axis x of n, so it is the x-axis is n and y-axis is x of n, right? So I have to plot it like plot 2d3. This is the command to plot the samples n comma x. This is plotting time domain sequence. Now subplot 3, 1, 2, and I want to plot magnitude response. How do I do that? Plot of 2d3 k, right? Magnitude of x of k, no? So that's why it is k, comma, and which one? Which parameter? This parameter. This parameter. So I'll just copy this and I'll paste it here. Control. This is how plotted magnitude response in second. 3, 1, 2. Second figure. Okay. Now in the third figure, subplot 3, 1, 3. Plot 2d3. So phase angle of x of k, so it is to be with respect to k comma phase. So phase is here. So this is what I want to plot. Control P. Fine. So if I run it, one, two, three, four. This is 4. Okay. So this is x of n response of x of k, and this is phase response of x of k. I can give title, I can give label for x-axis and y-axis, go through those 3 videos. And one important thing I wanted to tell you is that I can just have, I think this is the toggle data tip mode. Okay, so if you click it and if you click across this step, so you get the value of x-axis and y-axis. So x is 1 and y is 2. This is the second sample, no? So this is x of 0 is 1, x of 1 is 2, x of 2 is 3, x of 3 is 4, right? Now if I just click on this step, so I get this value. And if I click on this step, I get to see this value. Similarly, if you want to see at k is equal to 1, what is the magnitude? So it is 2.828, right? And this is 0, I guess, and this is also 2.828. So is this fine? So this is the theory part. Okay, so theory I can find 4-point DFT, I can find 8-point DFT, maximum if you give me the time I can find 16-point DFT. But in practical case, no, the number of points, capital N, will be in terms of 1000 depending upon the sampling frequency. Fine. So in that case I have to go for FFT command, which we have already done using FFT command here. And second thing I want to convince you is that you might ask me, sir, where is time domain and where is frequency domain? You said that x of n is 1, 2, 3, 4 and you are claiming that it is in time domain, and you said that x of k, which is this, so and you are claiming that it is frequency domain. How do we visualize it? How do we visualize this time domain and how do we visualize it frequency domain? Okay. Let me try to convince you that, but this is not part of your lab experiment. I'm just trying to convince you how to visualize time domain signal and frequency domain signal using this FFT, right? So because each and every time when I'm solving the problem, I used to say that x of n time domain, x of n time domain. I say x of k frequency domain, but how do we visualize it? Sir, where is time domain? Sir, where is frequency domain? What we can see is just a number. You write real numbers and you say that it is time domain, and you write complex number and you say that it is in frequency domain. But how is it? Right? So let me try to answer this question. Let me go back to let me close the window. So let me move back. This is not a part of your experiment, just I am trying to convince you, okay, how to visualize time and frequency. So first 3 line is C by C, here, close. So what I'll do, I'll take sampling frequency as 1 kHz, okay, and I'll define time, which is varying from 0 to 1 second, 0 to 1 second in a time step of 1 by sampling frequency. Okay, so when I say 1 by sampling frequency, what is this? What is the value of 1 by sampling frequency? In a time step of what? So my time start, yeah, so it is starting from 0 and ends at 1 second in a time step of 0.001. But instead of directly writing 0.001, I have written it in terms of sampling frequency. Okay, so but total length of this should be 1000. But when I define something like this, the total length will be 1001. Why? Because including 0. Okay, and even I included 1 as well. So I have to exclude the last sample. It should be 0 to n minus 1. I have to exclude the last sample. So for that, what I'll do, the last sample I'll subtract it by 1 by fs. Don't worry what I'm doing here, it's not there in your syllabus. I'm just trying to convince you. Okay, so the time is varying from 0 to 1 second, but I ignored the last sample because I need totally 1000 samples. If I don't include this, I get total of 1001 sample. So there will be an ambiguity. So that's why I just excluded the last sample, which is minus 1 by fs. Okay, so basically my time is varying from 0 to 1 second. Okay, so I'll define the signal x of t is equal to 2 times cos of 2 into percentage pi into, I'll take first frequency as 10 hertz. Okay, so 10 into t, and I'll add this to, let me copy this, Control C, Control V, and let me have 2 more just to give you an idea. Control V. Okay, so first signal is 2 cos, its amplitude is 2 volts and its frequency is 100 hertz. Second is its amplitude is 8 and its frequency, let me take 30 hertz. And if let me call this as 12, and up to where I can give these frequencies? Can anybody answer me? If I give 600, is it valid? If I give 600 hertz to one of this signal, will it be valid? Yeah, I give 600. So something wrong actually if I give 600. So what is that happening actually? What? Yeah, the thing is the sampling frequency which I have given is 1000 hertz. So sampling frequency should be what? Greater than or equal to twice the maximum frequency, right? So maximum frequency of any of these signals should be what? 500. So 500 into 2 is 1000. Okay, maximum frequency I can have is 500, but I'll give 400. So I'm not supposed to give more than 500, otherwise aliasing will appear. Fine. So I have a signal x of t which has 4 frequency component. One is 100 hertz, other is 30 hertz, other is 400 hertz, and one more is, let me give it as 200 hertz. Okay, so this has an amplitude of 2, this has 8, this has 12, and this has say 18. Fine. Now I want to find DFT of this signal. Okay, this is in time domain now. Let me show you first. The figure of 1 plot t comma x. Let me run and show you what's happening. DFT underscore demo underscore practical approach. Fine. So this is our time domain signal x of t. Or I can even, if I plot it in terms of samples, I'll get x of t. Okay. So this is our signal x of t or x of n. So can anybody answer me how many frequency components are there in this signal? You have to answer me because in front of you I have written the code. How many frequency components are there? 3 or 4 are. So I have 4 frequency components now, 10 hertz, 30 hertz, 400 hertz and 200 hertz. So this signal has totally 4 frequency components. Okay, so, but the thing is it's very difficult for us to visualize frequency domain component in time domain signal. That's the reason we take this time domain signal to frequency domain, where in that domain I can easily check or I can easily visualize how many frequency components are there. Okay, so we'll do that. We'll try to take this signal to frequency domain. So capital X, saying that it is x of k, is equal to, how do I take it to frequency domain? It is nothing but as simple as it is FFT. What is this FFT? It's a command which will find the DFT of the signal x of time domain signal x of. Okay, FFT of x. Okay, so by default, the number of points in x of n, whatever the points I have, the same point it will take if you don't give number of points. Okay, so how many points are there in x of n? How many samples are there? How many samples are there in x of n in this signal? Anybody? What is the length of this signal x of n? You can check it in your command window. If I type length length of x, so how many points are there? 1000 points. Okay, this has totally 1000 points. But while solving the problems, how many samples we usually take? In theory, we solved a number of problems, right? X of n. So what was the maximum length you have taken to solve the problem? Maximum 8, no. But in practical applications, how many points we have to take? It will be in terms of 1000, right? So just to convince you, I have given you sampling frequency as 1000. If I take sampling frequency as 50k, so I have to take 50k point DFT of this sequence. You're getting the point? Okay, so practical, I'm trying to convince you the practical thing, what and all the difficulties it is there. The theory is just 4 point and 8 point, maximum 16 point. Practical case, it is like 1000, depending upon the sampling frequency, that many point DFT I have to take. Okay, so in our case, I'm taking how many point DFT? I'm taking totally 1000 point DFT of this sequence. Fine. So FFT of x, so by default it will take the number of points as the length of this x of n, and the length of this x of n is 1000. So this capital X will be having totally 1000. In the sense, x of k is varying from 0 to 999. I have a value for x of 0, x of 1, x of 2, dot 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 up to capital X of 999. Okay, so we shall check it. I'll run it. Anyhow, I got the signal because I have plotted it. If I try to check, if I type capital X and if I hit enter, see what are this? These are all x of k. This is the value at x, k is equal to 855, k is equal to 856, k is equal to 857. So dot dot dot, k is equal to 999. Including 1, including that 0, it is the total, it is 1000. So totally I have taken 1000 point DFT. Okay. If you want to check the length, the command is length, length of capital X. You see, I am getting 1000, totally 1000 points. So I have taken 1000 point DFT. Fine. Again, you might ask me, sir, where is frequency domain? You are showing me just a complex numbers. How do we visualize this, saying that it is in frequency domain? Okay, so for that I have to extract magnitude and phase angle from this x of k. We shall extract magnitude and phase angle, and then we shall try to plot it. There we will get to know how many frequency components are there. So we will do that. So x underscore magnitude mag is equal to, what is the command to find the magnitude? Forgot? Okay, ABS. Absolute value. ABS stands for absolute value. ABS of x of k. In our case, it is x, right? And phase angle, for time being, we shall just keep the phase angle as it is. We don't want phase angle now. So I have the absolute. What I will do, I will try to plot it in a different figure. Figure of 2. Plot of magnitude x underscore mag. So I'm just trying to plot absolute value. Okay, plot of x mag, but there is a scaling issue here. I'm going to scale it, divided by, I'm going to scale its magnitude, okay, amplitude by half of the sampling frequency. Just don't worry what's happening here. I'm just scaling it by half of the sampling frequency so that scaling will be proper. The amplitude will be proper. Okay. So basically I have taken magnitude of x of k and I have plotted it. Okay. That's what I did. The way we did it in our experiment code also, the same thing I have done here. There I have plotted samples, but here I am plotting just continuous time signal. That is the only difference. Let me run it. Okay. Now we can visualize. So this signal is in what domain? And this signal is in frequency domain. Okay. I cannot say anything about frequency here, but when I take it to time the frequency domain using DFT, if I just expand it, and basically I have to concentrate from 0 to 500 Hertz because sampling frequency which I have taken is 1 kilo. So my maximum frequency component will be 0 to 500. Okay. I just have to concentrate on 0 to 500. Just ignore this part. Ignore this part. Why do I have this part? Because of the symmetry property of DFT. Do you remember I used to say second sample is complex conjugate of last sample and third sample complex conjugate of last but one sample and so on. That property should hold good here also. So since the last half samples are complex conjugate, just ignore this part. You consider only this part of the waveform. Let me zoom it. Okay, so do I have 200 frequency component in my signal? How many frequency components we had? Let me just open the code. I have 10 Hertz, right? I have 10 Hertz frequency component. What is its amplitude? It is 2. No? So if I go back to the frequency domain, I will be having an impulse at 10. So just try to zoom it further. Do you see an impulse at 10? Okay, so yeah, what does it say? There is an impulse in the frequency domain means that there is a frequency component at 10 Hertz. And what is its amplitude? Its amplitude is 2, right? See here, its amplitude is 2, right? And I have one more frequency component which is 30 Hertz, no? And this 30 Hertz, there is an impulse at 30 Hertz. And what is its amplitude? Its amplitude is 8 volts. So I have 8 here. Getting? Similarly, I have one more component of 200 Hertz. I have a component of 200 Hertz and its amplitude is 18, right? So I have a component at 200 Hertz here and its amplitude is 18. And one more component I have 400 Hertz. So its amplitude is 2. So is it 2? Okay, 12. So I have one more component impulse 400 Hertz and its amplitude is. Now I think you can visualize what's happening in frequency and time domain. So this is time domain signal. If you want to see more on frequency, just take it to frequency domain by taking DFT. I end up with this impulse. So that I can nicely see how many frequency components are there, what are those amplitude of those frequency components. Even I can check the phase angle also, but I'll stop here because